Let's get started. As usual, we've do a few minute introductions here. I'm sharing my screen. Few announcements. I'll slip through this. For people who are new, we really do try to create a learning environment. We continue to see this is just critical for all these changes going out there. GAI Insights is a for-profit firm that I founded with John and Jimmy Hexter and a handful of others, and we really are focused on education and thought leadership and analysis, and we're putting on a big conference here in a few months. If you want to get a recurring invite, send me an email and I'll stick it on the Google invite. People haven't seen, we've got case studies. We're behind on making more, but we do believe a lot in case studies, and video case studies are unbelievable. We do also believe in networking. We finally got another networking setup for the folks in Boston area. So August 16th, that's Wednesday, 6 to 8 at the usual timeout market in the Fenway area. Boston Red Sox are out of town. We had a great one in New York City, and we're behind on just getting that set up again. I'm working on continue to work with Harvard Business School on their summer generation Gen AI program. I did a presentation July 6th, which is online, coffee cups for left-handed people. It's kind of a base case for ChatGPT. It's free. You're welcome to go look at that. And we've got another one coming up this Thursday where we've got a little more advanced case and another case study. But a lot of people trying to learn quickly, and Harvard's one of them. And last thing is our conference, this inaugural conference. This is focused on enterprise Gen AI. This has got a lot of momentum. We're really excited about our speaker lineup. It's 2 days, September 12th and 13th in Boston. PwC is a sponsor. UBS just approached us last week. They're going to be a sponsor. Goodwin, the big law firm, they're a sponsor. And it's going to be a great learning experience. So if you're able to join, make the investment in time and money, we really encourage you, because it's going to be not only is it going to be a great event, we're keeping told it's one of the few events, if not the only one, that people know of right now that's really focused on the enterprise application of it, lessons learned at the case study level, not at the policy level or the consumer level. But let me turn it over to you. Please introduce yourself and tell folks what you're learning and what you want us to learn.
Okay, great. Thanks, Paul. Let me share my screen because I've got some slides here to guide me. Yeah, so as Paul said, my name is Julio Barros. I've been involved with machine learning and AI for many years, almost 25 years. I went to graduate school a long time ago for AI back then, and we did a lot of information. Oh, I got a little echo there. I had been getting a lot of questions. So now I work as a consultant to help people with their either implement or understand what AI can do for their businesses and for their workflows and for their products even. So sometimes if somebody has a software product and they need a feature added that would benefit from AI or machine learning, so I can help them figure out what they need to do. And I've been getting a lot of questions about vectors, and there's been a lot of press about vector databases. Vector databases have been getting funding, and people have asked me what vectors are and what they're for. Why would I care? And so I wrote something up last week, I think it was, and Paul saw it, and he asked me to kind of do a summary of that paper, or that little article here. And so that's what I want to talk about. So I want to talk about vectors and embeddings, what they're used for and what they're good for, and then talk a little bit about vector databases, and then we'll just summarize that. And then this is for people who are building something, not just using ChatGPT, but you're trying to build an application, or you're trying to add some LLM functionality to your application, some generative AI functionality to your application. And this is kind of a simplified structure of many applications that I think people would be using, where a user does something, either types in a prompt or maybe pushes a button that says, generate an outline for my use case, or whatever it is that they're doing. And then that request goes to your application. And your application does not necessarily need to send that request on, or that prompt on, to the LLM directly. It could take it and it could enhance it. It could manipulate it. It could split it up into multiple prompts. It could send it to multiple LLMs to kind of get a different answer, and then try to weigh the different answers and so on. And one of the really useful approaches would be to enhance that prompt with additional information specific to your use case. This is sometimes called a retrieval augmented generation, where ChatGPT in particular, was trained up to information up to September 21, doesn't know anything since then necessarily, and it certainly doesn't know anything about your private data or your business data, or it's not an expert on your specific use case. So you can enhance the prompt with added information and send that onto the LLM. ChatGPT and the API and other systems do have a way of calling back to you to get more information if they need it. And OpenAI calls these functions. It's kind of a generic name, but the idea there is that the LLM can also request more information from you if it needs to. So you might have a back and forth with the LLM there, also hitting a database to kind of do queries or whatever. So like, let's say the query is about inventory, about some inventory, about whether some particular product that you're selling is in stock or not. Well, the LLM can figure that out, that the user is talking about red sneakers or whatever, but only you know whether they're in stock or not. So the LLM can ask you back, like, hey, are these in stock? You can look it up in a database and then formulate a response to give back to the LLM. And the LLM can then turn that inventory data response into English, and then you can send that back to the user, type of thing. So the key idea here is that you don't have to just talk to the LLM. You can manipulate the prompt. You can do a lot of things with the prompt. You can add a lot of data to the prompt, and then you can use the databases to keep track of customers and conversations and so on and so on. Like I mentioned, the retrieval augmented context, it's also sometimes called in-context learning, is a really powerful technique. There's a lot of work going into reducing hallucinations and things, and this is something that can help now until more hallucination techniques are come about. But the idea is that if somebody has a question like, what is the company policy on parental leave or something like that, the ChatGPT may not necessarily know that, right? It doesn't know your internal operating, your internal employee manual. But then if you were able to search your employee manual to find the important pieces and then include that in the prompt and then ask ChatGPT to read the data that you send and formulate a good answer, that's actually a really powerful technique. So in this case, we would find all those sections of the employee handbook that deal with leave, maternity leave, paternal leave, just anything, sick leave, anything like that, and then let ChatGPT kind of digest that information and give back a coherent answer. The big question, though, then is how do we find the segments of the handbook that are handy, that are useful to answer this question? We're probably all familiar with like relational databases that you use SQL to query particular things, and those databases are great for when you're querying for a specific value or like a range of values. So if you had a bunch of records of like house sales or something like that, you could say what houses are for sale that are priced between $650,000 and $750,000 or something like that. It's a very specific thing. That's not the kind of database you would use to find like what part of my employee handbook talks about parental leave. That's a different kind of question. You may also have specialty data in your databases, including graph data or DNA data or a bunch of images or expense reports or something very specific. So you might want to be able to use that information, and you need a way to be able to find the relevant information in that database also. You may have a text search engine, a text search system, a database. A lot of these are usually Elasticsearch these days, but it works a little bit like Google, where you type in some keywords and then the system spit back documents that have those keywords. So you could use that kind of system to put your internal documents into, and then you could search for parental leave, and it would find all the documents that dealt with parental leave. A challenge with that is that you have synonyms. People might say leave, they might say vacation, they might say time off, and so on. And so if your system's looking for the word leave, it's not going to find these other documents that may be in there. And for same thing with parental, it could be maternity, paternity, whatever. It could be other words like that. So when you set up those kinds of systems, you usually have to go and create a big list of synonyms for all the words in your domain, because words aren't synonyms in every domain. They make sense in some places and not in other places. And you need to do a couple of other tweaks to kind of help it find that information. And that works to a varying degree. And then what's gotten really popular or really interesting is the idea of doing vector search. And I'm going to talk about what that is in a minute. Let me check the chat and make sure that I'm not doing anything. Actually, Paul, if there are any questions or anything I need to do, please let me know.
I will. You're doing great. I'll monitor the chat for you. Keep going.
Okay, great. Thank you. All right. So what even are vectors? Vectors, really, they're just a list of numbers. And if you're a mathematician or you do linear algebra, you have vectors and matrices, but that's not exactly what we're talking about. We really just mean a list of numbers. There are things like feature vectors that we use in machine learning, which is just like the columns of a row of a table, where you can have a feature vector for a house that's for sale, for the price, the number of bedrooms, the number of bathrooms, like the size in square feet or something like that. And that's a feature vector. Another really common vector type for natural language processing is word count vectors. You take all your documents, you split them up into words, and then you say you count how often each word appears in each document. And that can help you classify the document or understand what the document is about. If a document says baseball a lot of times, it's going to be about baseball. If it talks about DNA a lot of times, it's going to be about DNA. And you'll be able to kind of understand a little bit what those documents are. The word count vectors can be really big. That's just classic NLP. They can get really long because a vocabulary can be 10,000, 20,000, 50,000 words. And so you need a count for every one of those words. So this vector could be 50,000 numbers long, but it's just a list of numbers. When we're talking about vectors in like ChatGPT and generative AI and machine learning now, we're really talking about embedding vectors. And embedding vectors or embeddings, they're really learned lower dimensional representations of some piece of information. A lower dimension in that they're not 50,000, they could be a couple hundred or a couple thousand. And what they do is they represent they also call them dense, because if you look at the word count vector, a lot of the words don't appear in a document, so you'll get a lot of zeros. So those are sparse vectors. Embedding vectors tend to be very dense, and they're learned. And what happens is that when you do the learning, you set up a task that the system needs to do. And in the process of doing it, it comes up with these positions in this space that's specific to the task that you could then use to do interesting things with. So in this example, this is a very simple toy example where I said, let's organize food, and we'll organize food along the dimensions savory and sweet, and whether it's usually eaten for dinner or breakfast, right? And so something is sweet and it's dinner. That like ice cream is sweet and it's usually eaten, let's say, at dinner time. So I put it in the top right. Whereas breakfast burrito is not sweet and it's normally eaten at breakfast, so it's put in the bottom left in the left corner. So if you do this for a bunch of foods, you'll end up seeing that the foods that are close to each other are similar to each other because they fall in that same space, that same place in that same area in that space. And this is a two-dimensional space because we can really only see and think in two dimensions as humans. But if you did this for 500 dimensions or 2,000 dimensions, you can see that the system can come up with ways of classifying the different words or positioning the different words so that words that are similar, or I keep saying words because we're talking about ChatGPT, but you can do the same thing for images and customer records and things like that. But the piece of data that are similar fall close to each other in this space. So the vectors then also encode this domain-specific space. They're also called a latent representation because now once you've got this number or these sets of numbers, you could then do a lot of cool tricks on them. Like if I give you another food that's slightly negative on the sweet savory scale and is eaten at dinner, you know it's going to be similar to burritos, hamburgers, and tacos, and so on. Even though you don't know what the word is, you may not know what's in the food or whatever, you know that it's going to be close to those things. And you can start clustering those things. You can say, well, these are dinner foods, obviously. But again, this is a simple example. But if you did this for reviews, you could say, these are good reviews. These are happy reviews. If you did that for descriptions of wine or something, you could then start finding dimensions in there that you could then use to kind of group similar wines together based on their description. So that these vectors allow this similarity search, the semantic search. So you don't ask like you don't search by like the amount of calories in this food or whatever. You search for foods that are similar to hamburgers, and you get hot dogs and bean burritos and tacos and stuff like that, as compared to pancakes and waffles in this space, in this example. So you get these clusters, you get to analyze things, you get to find similar things. So if you do this for text, you can, let's say you do this for every paragraph in your internal corporate documents, then you can find the paragraphs that are similar to each other or that are similar to a question. So that's how you're going to find the paragraphs that deal with leave and vacation policies and things like that without having to search for exactly those questions. And okay, there are a lot of different kinds of vectors in use today. Some of the original, it all started with these word-to-vec glove embeddings a long time ago, being like 5 years ago. They kind of got enhanced and people came up with these sentence transformers. And then also OpenAI has an embedding service. You can embed a bunch of text. You can get the embedding vectors for text using the OpenAI API, using Cohere API. There's this instructor API embedding system that seems to be it seems to have a lot of promise that can be really useful for a lot of things. So the system's already in place. There are many ways to generate them. In my example, we just were laying out food on this two-dimensional map, but you can do handcrafted features like the word counts, but you can also use there are many different kinds of neural nets that you could use to generate the embeddings, including the encoding part of a transformer. A lot of times we're using the decoding part of the transformer, but transformers can be encoders and decoders, and the encoders will take text and then generate this embedding representation for you, this vector representation for you. And there are lots of different things, including autoencoders, which I'm going to talk about really briefly here in a minute, which are really useful for a lot of different things. So my suggestion is, if you are interested in this kind of thing, if you're interested in information retrieval, or it's something you want to add to your app, you can experiment with lots of different embeddings. You can probably just start with the OpenAI. Their API lets you query this text embedding ADA 002, and that's a really good embedding. It's useful for a lot of things. For normal, regular, everyday English, it'd be really useful for that. If you have very specific medical text or legal text, you might want to train your own. And it's not that hard to train your own. You might want to get somebody to train it for you, but you can. But it's certainly possible to do that. Creating your own embeddings, I want to talk real quick. I know we mostly talk about text, but there's a thing called a variational autoencoder or an autoencoder, which can actually take almost any kind of information. And what it does is it takes information on the input, it squeezes it down into this compressed representation, and then it expands it back out. And all it's trying to learn when it's learning is an output that's exactly the same as the input. And you think that's ridiculous. Like, why would you waste your time doing that? But the idea is that in that process, it's got to go through this really narrow passage. And so it's got to create this compressed and coded representation of the data so that it can expand it back out and minimize the error. So then you throw out the expander part and you use the encoded middle part, the encoder bottleneck, and then those embeddings can be really useful to do what I'm talking about here, with not just text, but with data records, insurance policies, images, audio, just like anything, you can do it like that. The other interesting thing is then now you've got this encoded representation. What if you just add a little bit of noise and then you expand it back out? You'll get something similar to the original thing that you put in, but different. So that is kind of the foundation for a lot of the generative AI type of things, where you can take something, tweak it, compress it down to some kind of representation, and then tweak that representation and expand it back out, and you generate something else. Then you can also take this for text and, let's say, audio or images, and then create another model that combines the two. And then you can then go from text to images or from images to text. That's really a really common way to do something like that. So images to text would be like captioning an image or describing what's in an image. And text to image could be like generating images from text. So,
excuse me, Julio, we do have one question here. What is the meaning or significance of labeled data set?
In this case, we don't need labeled data sets. This is unsupervised learning or self-supervised, where so we don't have labeled data in this case for right now for the embeddings. When you have labeled data, is you have a bunch of text and let's say doing semantic sentiment analysis, you have a bunch of, let's say, movie reviews, and you want to say whether these reviews are positive or negative, or people liked them or didn't like them. Well, that liked them and didn't like them are the labels for that text. In this case, we're trying to learn a lot of the structure of the information without the labels. All we're trying to do is find ways to lay the text out or in this space where the similar things fall together. And then we can use that to do the labeling or the classification to a lot of other tasks later. I hope that answered.
Yeah, Dave, did I answer your question?
Oh, sort of.
Hey, Julio. This is Bob. One of the places I've seen, if I understand correctly, the use of labeled data is during fine tuning. So in other words, you generate LLM, and then they use labeled data sets where they're trying to guess what the correct word is. So they'll remove one word and then run it against a known labeled data set and correct the model to make sure it matches. Is that a use here?
I would say that's close. When you're doing the fine tuning, you don't necessarily need the label. Labels are really useful when you're going to do classification, when you want to do semantics.
Okay.
Like you want to do sentiment analysis. You want to know that this piece of text is positive or negative. With fine tuning, what you're doing is running this training process on your data so that it learns more about your data. So instead of using general English, it starts using medical English or something like that, right? Or
Okay.
legal English. So that data isn't really labeled. It just is the data. So it learns that data structure. The labeled, a classic thing is like, you want to know whether an image is a cat or a dog. The word cat and the dog, those are the labels for the images. You could just have a pile of images and you have them classified into cats and dogs. So those are the labels. What I'm talking about here for the embeddings is you have a pile of images and you're just going to learn the inherent structure in the images without having labels for them, without having any more information about what the images are. You're just learning some inherent structure. You could then use that structure, which is those embeddings, to do other things like classification, like clustering, like generating other images that are similar to them, and so on and so on. Okay.
Thank you.
Thanks for raising your hand, everyone. David, you had your hand up. Go ahead.
Julio, what is your meaning for the use of the word semantics?
I think when I said semantic, I probably meant sentiment, because I don't think I meant to speak about semantics in this talk. So I'm sorry, I think I misspoke. I meant sentiment. And that's where you would use the label data. If you have a bunch of text and you want to say the sentiment is positive or negative, it's negative.
Sentiment meaning, so cell phone company recording, listening to the conversation, and as the customer gets increasingly pissed off, the words get angrier and angrier. So sentiment, that would be one reason you would use sentiment analysis.
Sure, absolutely. That'd be one reason. You might want to pull down all your reviews from Amazon and then see what people think about your product. And so you could say whether the reviews are positive or negative. There are reviews about restaurants, reviews about movies. That's kind of a common sentiment thing.
Good enough. Thank you.
Okay. All right.
Julio, if you don't mind, just a few more questions on chat.
Sure,
One is on the video. Is video considered multiple images, one encoding per frame? Mike Novak asked.
Yeah, that's a huge question. That's a really good question. You can, except that you also need to then find ways to keep the consistency between the encodings between the frames, depending on what the task is that you're trying to do. So a lot of times it is one encoding per frame plus another one for all the frames over time. Again, depending on what you're trying to do.
Right. So you're able to encode a series of frames of video, like a 10-second video can be encoded into a single result set.
Yeah, you could.
Wow. Okay. Yeah. Thank you.
Yeah. You could, and I don't know, like I'm trying to think of some examples for video so much, but audio and music and stuff like that. So like Shazam is able to listen to a little bit of music and then tell you what that song is. They've encoded little sections of the song, and then they're able to kind of find that match really quickly. And you have things like time series and stuff, like in financial applications, you have price information that changes over time. And so that is also encoded in kind of a sequence of things.
Great. Keep driving, Julio.
Okay. All right. So vector databases, now we know a little bit about what embeddings and vectors are. Vector databases just help you manage them. They help you when you create one. You want to be able to store it somewhere so you can use it later. You want to be able to read it. You want to be able to update it in case your document changes. You want to be able to delete things. And then kind of importantly, you want to be able to search things. If you're going to encode every document, every paragraph in a document, let's say, at some point you're going to get a lot of different vectors. And so you can manage a lot of them just in code kind of manually, or you can manage them in some kind of database, and the database can help you really do that faster, easier, more efficiently and everything. The traditional databases like Postgres and like Redis, those are common. Those are traditional kind of databases, kind of. They've added extensions and plugins that you can use to help you manage vectors. So you might be able to use your Postgres database to do that. I would recommend that if your application isn't very big, if you're not, if you're not OpenAI or Uber or something, because that just simplifies the whole process, and Postgres will be good enough for that situation. If you have very large systems and you have very demanding needs, then you might want to go to a vector database. And a vector database just kind of all it does is manage vectors. So you don't use it to query the house prices or the dates of anything or anything like that. You mostly just query it to do the vectors. Having said that, these two kinds of databases are kind of coming together a little bit. We're adding vectors to traditional databases, and people are adding traditional queries to vector databases. But still, right now, you might want to use one or the other, depending on what you're trying to do. One particular example, there are a lot of them. I think Pinecone and Weaviate get a lot of press. ChromaDB is a kind of a newer one. It's a smaller system, but it's one you can embed in your application. So a vector database can run right in your application. It could run in your system, on one of your servers, or you could just let somebody else manage it. And that's the way Pinecone and Weaviate work. They are third-party hosted databases, and so you can just send them the data and send them the queries, and they give you back the answers. But for people involved in coding, using something like Chroma is pretty straightforward. You create the client, you choose your embedder if you want something different than the default. The embedding function, there are lots of them. You can say use OpenAI, use Cohere, you could use this sentence transformer. You create a collection, which is your collection of data of text you're gonna shove into this database, and then you just start adding documents to it. You need an ID so that you know what document it was when you get the answer back, you know what document they're talking about. I didn't have IDs, so I just numbered them all. But you do that, you just shove a bunch of text in there. And what I did was got a bunch of headlines and shoved them in the database. Then I have a very simple query here. It's just malaria. And I queried my collection for the word malaria. It's just headlines, and it's just the word malaria that I'm querying for here in this example. And what you get back is what to know about malaria. Now, this uses malaria, and this document would have been returned by a regular text search kind of database because the word malaria is in both systems, right? Or the word malaria is in this headline. But who raises alarm on disease in flood-hit areas of Pakistan? That doesn't say word malaria, but somehow the embedding for malaria was probably pretty close to the embedding for disease. And so it said this document being this sentence, this headline, is related to the query that was given. And same thing for polio, and the same thing for vaccine and coronavirus. Those are all kind of disease-related things. So the system was able to find things, and they were able to find documents that were similar to my query, which was simply the word malaria. Some challenges are that the prompt itself is not always really the topic of the question. So in many cases, you need to understand what the user is really trying to ask, and maybe understand why they asked in a particular way, and you can reshape that prompt, reshape that question to be something better for your document database to extract and for the LLM to kind of to work with. Still a little work that can be done on partitioning the document to coherent sections. I said paragraphs, is paragraphs the best way, or pages or chapters or whatever, that's something you need to think about. And maybe your data is not exactly a text document. So maybe it's a different way to break it up to create the embedding vectors. Like the question about videos and stuff. If you were going to do videos, how would you want to break it up? Do you want to embed every frame, put that in the database, or do you want to try to come up with a scheme to encode, 10 seconds worth of video, or maybe the whole video? Who knows? You need to kind of look into your particular use case. And then you can find creative ways to do your own embeddings. Like I said, we're dealing with text. Most of the stuff we do is text, but this is really, really powerful technique for your sales data, your customer records, your video of the house inspections you do, your biology experiments, your DNA database, all that stuff can be embedded. You can come up, I believe it's possible to come up with a useful embedding for almost any kind of data that you have out there, relationship data, graph data, all kinds of things. All right, with that, I think I'm out of time. So thank you. Summary, you can modify the user prompt and create new ones. You can enhance the prompts with your own data. You can use vectors to find the right data to put into your prompts. And you can create your own embeddings if you really want to. But the ones that are out there are really good for text. So I would just look at the OpenAI and Cohere ones. They're very good. They're very good. And I know that we're just learning about vectors, but I think that finding vectors in text, I think there's lots of possibility for embedding all kinds of information and enhancing our prompts with all kinds of information out there. So thank you.
Great. Wonderful job, Julio. Thank you so much. How about more questions? Raise your hand, I'll call you. And go ahead, Bob.
Yeah, so I have a comment. Julio can comment my comment, and then a question for Julio. So the comment is that with Anthropic's Claude getting a lot of publicity with regard to this new V2 coming out. In the technical community, they're talking about the issue with regard to having 100,000 or million token size context windows. In particular, it's this what's called a lost in the middle problem. So in other words, prompts do well at the front, prompts do well at the end, but they do pretty lousy in the middle. And Guido Appenzeller, who is today works for A16Z, the venture capital firm, but used to be the CTO of Intel and then later VMware, said, okay, we're back to using vector databases again. So in other words, context windows of 4K, maybe up to 16 or 32 are about the maximum that these GPU engines can handle. And the rest of it, when you have really large data sets, should really go into vector databases for retrieval, particularly when you get into books and stuff like that. So that's my comment. I looked for Julio's comments with regard to that. And the question is a different question. I'll make it short. Maybe now, Julio, you could kind of explain what parameters are in English language with regard to when you look at this trade-off between context window size and number of parameters, because that's not getting a lot of publicity given the growth of LLMs.
Sure. And I'll just be really quick because don't have a lot of time. But actually, I want to say, if anybody has any questions or wants to go deeper into any of this, please just don't hesitate to contact me. I'll be happy to talk about anything, in depth. First, with the context windows, I am super excited about longer context windows. I think that's fantastic. I would still not be surprised if you get the best results by giving the prompt the best information you have. Just because you can shove a bunch of garbage into that prompt doesn't mean that you should, or that the prompt will ever be able to do it. And I read that paper about the middle of the context problem, where the LLM is better at paying attention to the beginning of the text and the end of the text. But even if they solve that, it's going to a larger window, a larger context. The more data you give it, the longer it takes, the more expensive it's going to be, and the more chance you have for it picking up on something that you didn't want it to pick up on. Just like anything else, you want to increase the signal to the noise with the prompts. And then your second question with parameters, usually I don't know if you mean parameters in regard to the context window, because usually the context window you're counting tokens.
No, I know that. I'm okay. Sorry. I'll withdraw the question for now because I need to explain a little bit further, and it's related but not directly to your subject matter here.
Well, I would just say parameters is really just the size of the model. All these models are really just a bunch of matrix multiplications. So matrix times vectors times matrices times other vectors, and the size of the matrix, the number of numbers in the matrix and the vectors is really, each one of those numbers is a parameter. So when you say a model is 7 billion parameters, it basically has 7 billion numbers that it's going to try to multiply together over and over again.
That's great. Let's do one more. Michael do.
Yeah. So first, one thing to add is I know there are some open source packages they can do this kind of try to do it end to end. So for example, Llama Index. So what they do is they offer they basically do the vector database and the connection to the large language model, and then do the query kind of all put all the things together. That's one thing for the audience to be aware of. If you want to use it, you can try it out. And the other thing is a question are you aware of some other open source packages that can do similar things? And do you know which one is kind of the best on the market?
Similar things to Llama Index? Yeah. Well, I think the two leaders are Llama Index and LangChain. So I think there's somebody here that has worked with LangChain. So those would be the two to check out. I think I have heard of other ones, maybe that try to be a little bit simpler, but they're not coming to mind right now. If you really want, I can look them up for you, but I don't think. I can't.
Okay.
LangChain and Llama Index are the two.
Okay, thank you.
Mm-hmm.
Yeah.
Well, good. Well, let's finish that showcase. So, Julio, thank you very much. Really appreciate the work and the contribution to learning. So, last few minutes we have, let's open up the kind of open mic. Folks want to share other use cases they've had for ChatGPT, or things they've been blown away by, or one-on-one questions, or insights they have from using Claude or any of the other tools? Go ahead, Mike.
I'll always throw out a good one. So, Julio, have you heard anything about federated LLMs?
I haven't heard that term, but it sounds like you mean like the panel of experts kind of thing, or something?
Yeah, as opposed to federated databases, I could have, everybody on this call is their own LLM, and we can, chop up the information and the data in different vectors, and we all share, etc.
Yeah, I don't know too much about that. I do know that
hypothetically, could you have two LLMs that could coexist and work together, or would it just not be technically even worthwhile possible?
Oh, no, absolutely. And that's actually what I was trying to point out, is that your application can split up the prompt and either send the same prompt to multiple LLMs or send different kinds of prompts to different LLMs, and then somehow collate that information and either collate and analyze it itself, or take that collated information and send it to some other prompt for some kind of summarization or further processing. So all that is very possible. And I do think that's the way we're going to go for a lot of things.
That's great. Thanks.
Especially instead of having like one giant OM that knows everything, you can have like specific ones that know specific things and use them differently for things like that.
Thanks. Let's go to Stephen K.
Yeah, thanks. This is way off topic, but I'm looking for two different people. One, somebody who knows AI, but has some experience in the VAR, reseller, MSP space. I got a group of people from that industry who want to learn more about AI. And then the second request is a person who lives in the Silicon Valley, because there's a group of German business people coming to town and they want to see somebody face to face who's got knowledge of AI. So again, thanks for indulging me. If you know anybody like this, please send me an email. Thank you. Appreciate the time.
Thanks, Steve. Go ahead, Valerio. I'm hacking your name. I apologize. Sorry, buddy.
Very good. Very good. Hi. Thank you. My question is related to what has been presented today and a connection with what an LLM can do with respect to that. So just to double check that my understanding is correct. So when you try to search through an encoded data set, how different that is with respect to asking a language model to look for something within the training data set of the language model. So in a sense, if I search for an information in a encoded, decoded data set, and that is going to be quick and probably precise and so on and so forth. So how much that is different with respect to asking a language model to look for something within the training data set and give me an answer regarding to that.
Well, I mean, in some ways it's similar, but I think that the mechanism is very different. Like how the search is going to be done is different. The key thing is that the LM may not know your particular, let's say, private data. It doesn't have to be private data, but data that you've accumulated. So you may want to search just that data for something to give to the LLM. And then the other big difference is that when you do that search, you're just going to get a list of documents that have some kind of relevance to your query, but it's not an answer yet. So that's why then you can take that list of information, pass it to an LLM, and say, hey, summarize this or answer the question using this information. So that's how the two different systems would work together.
Great, thank you.
Well, is Rosemary, are you still here?
Tim, do you want me to chime in here a little bit, Paul?
Please, go ahead, Tim. Go ahead.
So here's the reason this is important is let's say you're a biotech company, or let's say you're a pharma company, and you have reams of information about all the different drugs that you've tested and all the ways that you've run them through pipelines and gotten various results back. And what you'd like to do is say, gosh, does any of that apply to any of the research literature and the reams of research literature out there to Alzheimer's disease or cardiac problems or whatever it is you're interested in? So the latter question, tell me about all the Alzheimer's research out there. That's a great question for an LLM. as an example, if it's because a lot of them have ingested a lot of this information. The former question, it has no idea about because all those results are proprietary to you. And so somehow, if you want to combine them, you have to get your data in a form that these LLMs can understand. And that's what these vector databases can do. I think Alden had a plugin that he talked about that did something like this, right? Where it would sort of suck your data into a Pinecone database and then merge it with an LLM. And now you can say, tell me what of my research is relevant to this particular compound that's found in Alzheimer's disease patients.
Correct.
That makes sense?
Yeah. Yeah. But you want to start with your data first. You want to make your Pinecone database with your pharmaceutical data first. That is the main thing.
Right. Yeah.
Right. And then you want, hopefully, to keep the results to that data set, not have ChatGPT just go searching around for information.
Right. You want to combine the two and have it targeted at your information. And of course,
Correct.
There's a whole issue of, do you want to put your information, make your information available to ChatGPT in ways of containing it so you don't violate your privacy issues and things like that. But generally speaking, I'm just saying, if you have your own, some set of data that's not in vector form and you want to get an LLM to talk about it, you have to get it in some sort of vector form that they understand.
Correct. Step one is take your data, make it into vectorized form, put it in Pinecone, then search it, and then use the ChatGPT API, not ChatGPT public interface, to do your searches or to answer your questions.
That's great. Let's thank you, everyone. Let's do two more questions or contributions or comments. I'll stick in the chat. People have seen this. What's happening with text to video is pretty amazing. And I wrote a blog post for people who haven't seen some of these text things, but it's quite stunning what's going on and to think about where that's going to go. So it's well worth a minute or two for people who haven't seen text to video.
Can I pile on? The same is true with text to voice. Text to voice has been around for ages. And I'm just now starting to see some companies say, hey, we got the newest thing for generative AI. What's that? We're going to put a voice in front of it so you don't have to type. You can just speak to it. It's like, yeah, it's very efficient. And we'll see how it works in the market, how well it's accepted. But that's going to be the way forward.
Well, thanks, everyone. Let's end 5 minutes early and let's keep the momentum going. This is an experiment that started in January and we're sitting here in July and we're still getting value out of it. So the world keeps changing. And thanks, everyone, for your learning and contribution and have a great evening. Thanks, everyone.